Hello class. In this video we're going to start taking a look at classes and objects in Java. What is the building blocks of object-oriented programming? So up until now we've looked at a lot of primitive data types. We've looked at a lot of selection statements such as ifs and switches. We've looked at repetition statements, which we have our loops, our for loops, our while loops, and our do while loops. We've looked at sequence statements, which again are basic assignments and calculations and your printing statements and your scanner statements and all that jazz. And to an extent we looked at arrays, which are a little more than a primitive data type, but they still only hold one type of data, meaning an array of integers or an array of floats or an array of doubles or something like that. All the same. So now that we're going to get into classes and objects, we're going to look at how we can build a data type that holds different types of data, perhaps strings and integers and floats and arrays all together, as well as defining separate functions and methods to access that data specific to that object. And that's the basics of object-oriented programming. You have an object which has its own set of data, and you have operations that you can do on that data. Further, we have what's called a class. And a class is what is used to define what an object will look like. You can consider that as the template or the blueprint of an object. So from one class, you make many objects, potentially. So as we go through this little video and start talking about classes and objects, we're going to look at section 8 of our book, which is called Class 7, Classes and Objects. This will be a 2-week lesson, meaning there will be classes and objects in Class 7 and Class 8, because it's a rather involved topic and I want to spend a bit of time on it. And we'll be using classes and objects for the remainder of the semester to represent all our data. So we will be looking at what is an object. We'll be looking into how we use a class and define a class. And then we'll look at what they call mutators, accessors, and private helpers, which sounds a lot more scary than it really is. It's very simple, and I'll have some slides and demonstrations about that. And then we'll go through an example. I also have some other examples in the slide deck that we're going to go through now. I've also gone ahead and opened up our test area. I'm going to open that up into a new tab, actually, so we have a full screen view of it, because we're going to be writing some code for this in a little bit. So as that's opening, let's jump back over to our slides and we'll take a look at a little more detail. What is a class and what is an object? So as I said a minute ago, a class defines the structure and the object is the structure. And I have listed a few examples down below, and you can really think of almost any example you want. Objects are meant to model real-world items, whether it's a car, a cup, or a student, or just about anything you could think of can be modeled as a class and a sequence of objects. So for an example, we have a car, and you're probably thinking of a car right now, probably your own car, or maybe somebody else's car, and you could think of some items that would define your car: the make, the model, the year, the color, the price. What else? There's probably a bunch of other things you could think of that would define your particular car. Now, that defines in general the car class. Now, a car object would be an individual car, like a Toyota Camry from 2019 with the color of red and a purchase price of $35,000. Yes, cars are expensive. So that would be an example of a car. So your individual car would be an object. The concept of the car would be the class. Now let's look at another example, a cup. You're probably thinking of a cup right now. What kind of cup do you have? I have a coffee cup. Does it have a handle? Does it not have a handle? Does it have a lid? Does it not have a lid? How big is it? What color is it? Can it hold hot or cold or both? So all those would be different things that would define the cup. The actual object of a cup that I'm looking at right now is it's a paper cup. It is yellow, could be white depending on where I bought my coffee from in the morning, and it's 24 ounces in volume, because I really, really like coffee. You can have smaller cups, you can have bigger cups, made out of different material and different colors. And finally, our third example would be a student. Think of yourself. You have a name, you have an ID, you have a social security number, you have a birth date, you have a gender, you have a list of classes you're attending, you have a height, you have a hair color, you have an eye color, you have all sorts of things that define you as a student and you as a person. All those items together define the class of a student. Your individuality is the actual student object. It kind of distracts from what it really is, but a student itself would be your own name, your own ID number, your own social security number, your own birth date would define the individual student. And that's a basic synopsis of what a class and an object is. So again, a class defines the overall structure, and the object is the actual structure. Another way you could think of it, now that we're getting up on the holiday season, is you could think of the class as the cookie cutter, and perhaps the object as the actual cookie, for those of you who make Christmas or holiday cookies. Okay, let's put this into practice a little bit. Let's define a class to define what a dog is. Well, first we have to give the class a name, and you'll see we're going to call the class dog in a burst of creativity. We'll call it dog. And you notice now we're creating variables with capital letters. And I think I said this earlier on in the semester, that variables should start with lowercase letters except for classes. Classes start with uppercase letters. Now, where have we seen a class before? Well, we've seen it here in our example program, our lab program, class lab program. So we are defining a class, and we're calling it lab program. We're going to create another class called dog in a second. And the dog class, again, starts with capital letters, unlike variables. So each dog will have a certain number of attributes, and those attributes we're going to represent by variables, or what's also called the fields. So same name, same item, different names. So an attribute or a variable or a field all refers to a specific data type, an integer, or a float, a double, a string, something like that. And we're all very familiar with those. So what other kind of attributes can a dog have? Well, a dog will have a name, we'll have a breed, we'll have an age, we'll have a color, probably a whole bunch of other things too, but we're just going to keep it simple for now. And you can define as many different attributes as you'd like, but we're just going to go with the 4 for now. So one of the tenets of object-oriented programming is that in each class and each object, there are methods defined or behaviors that are created that operate on the data in that object itself. And it's all self-contained, meaning the methods that you create for an object only exist and work on the data for that object. So it encapsulates all the data and operations you can do on that data in a single entity. So things a dog can do. A dog can bark, it can sleep, it can eat, it can do a whole bunch of other things, but again, we're just going to keep it simple. So we have our 3 methods, our 3 attributes, bark, sleep, and eat. We have our 4 attributes, or variables or fields, name, breed, age, and color. So now let's see if we can put that into what it looks like in code. But before we do that, let's look at the syntax of what a class is. So here is your basic syntax, and if you've compared this to what we've been doing all along with our main programs and our lab program, especially over here in our testing environment, you'll see that we have public, class, and class name. So class name is the name of the class that we're going to make objects from. So in our particular example we're looking at now, the class name is dog. The attributes, well, the attributes we said were going to be the name, the breed, the age, and the color. So what kind of variable types would be used for that? Well, name, we would probably use a string. Breed, we'd probably also use a string. Age, well, we could use either an integer if we only wanted to track in years and entirety, or months, depending on how you want to track age. And color, again, would be a string. So we have 4 data types we're going to create. And here's our variable declarations. Skip constructor for a second, but we're going to come back to other methods. Other methods would be the attributes we just talked about, the bark, the sleep, and the eat. So these would be methods that we're going to be defining that can operate on that data. Now, the constructor method. The constructor method is a special method, and it is the method that we're going to call when we use that new, remember that new construct where we use for scanners, and integer and arrays where we had said new. New is what is going to tell the compiler that we're going to create a new object from the dog class, and we're going to assign it specific values to initialize these attributes. So when we create our dog object, we want to give each one a name, a breed, an age, and a color. And we can use the constructor method to do that for us in one statement. It's a way of initializing the object to its default values, similar to how we would initialize primitive data types to a value. Okay, so let's review. What do we need? We need a class name. The class name we picked was dog. We need data. We need the name, the breed, the age, and the fur color. And now we need some methods. We need the create new dog method, the constructor. We need a method to set the dog's name if we want to change its name. We want a method to return the dog's name so we can have access to that piece of data outside of the object. And I'll show you what that looks like in a second. And then we need another one to set the breed, to set the age, set the fur color. And similarly, you can create other methods that would get the name, get the breed, get the age, and get the fur color. And here is a brief example of what this code looks like. And we can see we have public class dog, where we're defining the class. Here are our class fields. We have the string name, string breed, int age, and the string fur color. Now you'll notice I put in front of them all private instead of public. We've been using public for all our variables in declarations earlier, but now we're looking at private. So private tells us that these variables are available only inside the object, meaning you cannot get access to those variables from outside the object without using one of the methods to get that value. Hence the get methods, get name. So you can see we have down below, we have our get method, public string. Public means it's available to everybody. String means it's returning a string value. And get name. Get name is the name of our method. It takes no parameters and returns the variable name, which is here. Similar, get age does the same thing, but for the age. And here below we have our set name method, which now returns nothing, but takes a parameter of name, p underscore name, and it takes the value and assigns it to the name variable. So this is a way we can manually set the name. This is how we can get the name out of the object. Now, to the constructor. This is the constructor method, and you'll know it's the constructor method because it has the same method name as the class itself. Public dog, public class dog. So dog is the name of the constructor method that will build our new dog object. Sounds weird when you say build a dog, but that's kind of what we're doing. We list the parameters that we want, the name, the breed, the age, and the fur color. And again, I like this naming convention of putting a little p underscore for parameter so we understand which one is which. It helps keep our variables identified. And then we simply set the variables in the object itself to the name of the parameter. 1, 2, 3, 4, name, breed, age, and fur color. And now we have, with this, created our dog object. So I'm going to copy this code, and I'm going to come over to our lab environment. Now you'll see in our lab environment, we have the lab program that we'll be using all along. And you'll see we have our, oops, it's all kind of off the screen, so let me bring this down a little bit. We have our lab program.java. Well, we're going to create each class in its own .java file. So we're going to expand the editor by clicking on this little paper icon. And we're going to add a file. And we are going to give it its name, dog.java. Because we're creating a dog class. And if I click into it, you'll see it opens another tab on the right, and we have our lab program.java, the original. We have our dog.java on the right. I'm going to paste our code in there, and it really did not paste very well. So I'm going to pause the video for just a second in your time, and I'll make all these changes and clear it up, and then we'll have a nice clean version we can edit. Okay, there we go, all cleaned up, ready to go. We have our class dog, we have our class fields, they're all marked as private. We have our constructor, which sets the initial values of all the class fields. We have our methods, the get methods to get the name and the age, and the set method to set the name. So if we come back over to our main program, we can run it. It won't do anything because, well, we haven't written any code yet. But you can at least see there's no syntax errors, which is nice. So if we come back to our slides, we need to take a look at how we can create an object from that class. And we call that instantiating an object, or creating an object from an instance, or creating an instance of an object from a class. And you can see here we have our original primitive variable types, int var name equals 10, where we have a data type of int. We have a variable name of var name, and we're giving it an initial value of 10. Well, when we try to create an object from a class, we have our data type, which is the class itself, dog. We have a variable name, which again is a variable name, same as before. And now we're giving it this new constructor, which tells the compiler we're going to build an object, and it's going to set aside whatever memory it needs based on what was defined in the class to create those class fields, the name, the breed, the age, the fur color, and it's going to create that for us. And that's what this constructor does. Now you'll notice that in our example, our constructor had 4 parameters. We have the parameters of name, breed, age, and fur color. So like any other method, we need to provide these particular values when we call the constructor or any other method so the compiler works properly. We need to match them up. So we need to pass in a name, a breed, an age, and a fur color. So let's take a look at what that looks like in our code, in our zybooks. And we will give it a name, a breed, Schnauzer, and yes, this is my dog, and fur color is gray. And we need to close in parentheses. So I now have created my dog object, the dog's name, dog's breed, dog's age, dog's fur color. If I run this, what did I do? Oh, I know what I did. We have to delete this extra line of code. We don't need that. Make it match up with the example like in the book, and we'll try it again. And it produced no output, which is correct because we did not print anything. We just created our variable, here in this case an object, and exited the program. So while that was interesting and it worked, it's not very exciting because it didn't do anything. Well, let's take a look at how we can get access to our data inside the object so we can actually do some stuff. So we'll come back to our code, our slide deck here, and we're going to talk a little bit about now how we can get access to our data. And the book refers to it as an accessor method. This is part of that section. It says accessors, mutators, and private helpers. Well, an accessor is a method, and all this method it does is get the value you're asking for. So, for example, this method here is going to return the name. That's all it's designed to do. Get the value you want to use. So your code would be using mydog.getName. So you notice this dot syntax now. You have the object, the dot, and then the method. So that is telling us, the compiler, that on this particular object, I want to use this method with whatever parameters, if any, are necessary. So let's see what we can use for a get object and try to write our code so we can get the name out of the object without accessing it directly. So if we take a look at our dog.java, we have a getName method, so we can use that. And we're going to go over to our code and we're going to write just a print statement, print line, same as we've always done. And now it's my dog dot get name. And this is going to access this method in the myDog object. MyDog is a variable of type dog. And if I look at dog, it says the get name method is going to return the name, which we had set here earlier from the constructor and set it to do this name variable in the object. So if I run this, sure enough, it prints my dog's name. So we know that works great. Now you may be thinking, well, why can't I just get the name directly? Well, I can't type that name and get the name directly, because that's what we called the name variable. We called it name. Why can't we just get it directly? Well, let's see what happens. Well, as you can see, we did get an error. The caret is pointing to this operation .name, and it says name has private access in dog. Well, that comes back to our private now. This variable is only accessible inside the object and can only be referenced by using a get method, an accessor method. We do not have access to the data of the object outside of the definition directly. We can only access it through methods. And that's what this, that's the beauty of objects. The data is hidden. It is encapsulated. It cannot be accessed directly from the calling program. It's protected. So we have some nice features there. Had I made this name public, for example, and then I reran the program, sure enough, it works, because now I've made this variable public and everybody has access to it. But I don't want to do that. I want to keep everything private. I don't want people to be able to touch my data without using the right tools to get to it. So coming back to here, we're going to delete this line here because we know it is not correct and we don't want it. Let us take a look now at a different type of method. The next type we're going to look is a mutator method. Now, a mutator means mutate. So mutate means change or set, also referred to as a setter method. So a setter method allows us to set a variable in an object, set a value in an object. Since we don't have direct access to those fields, we can only access them through setter methods, and this is how we would do it. So if I wanted to give my dog a birthday, I would go in and I would do something like this. mydog.set age 13. And what that does is takes this value of 13 It looks up the setAge method in the myDog variable, which is from the dog class, so we can go to dog class. I have the setAge method. I do not have a setAge method, so we're going to create one right now. Public void, because we're not returning a value, setAge int p age. Our parameter is the age that's coming in, and I'm going to do age equals p age. I'm going to set the age. Now, you'll notice that my method is public. Well, I want my methods to be public, otherwise I would not be able to access them either. So the methods would be public so we can get access to the tools to work on the data, but the data itself should be private. So just keep that in mind. So now I have a setAge method in my object. I have a setAge here, and now I can do a system.out.println mydog.getAge. I'm going to get this time and see if it prints either 12 or 13. I would expect it to say 13 now since we just changed the value. And there it is. So I was able now to update some of my data with some set methods. I was able to get those values back with some get methods. So now we have getter methods, we have accessors, we have mutator methods, we have setters. So we have access to our data for reading and writing and updating as we need. So how can we use an object in our code? Well, we kind of just did that a little bit. We set up a dog. I called it Ruby as the name instead of myDog, but you can get the general idea. Here's the name of our object. Ruby, we can get the name, we can get the age, we could set the name, we could set the breed. Ooh, I left off a parentheses here, I'll have to fix that. And you could see we can set them individually. We talked about the dot syntax. So the dot syntax is telling us to use this method on this object. Because when you create multiple objects, you're going to have different object names, but the methods will all be the same. There's going to be a get name for every object of the type dog. They're all going to be the same method. So the dot will tell us which variable to access. So variable name dot object method. So if we wanted to create a second dog, we can do that too. And it's very simple. If we come in here and we do, again, dog, I think I called it Holly in the other book, new dog, and we'll give it a name of Holly, and I think I said it was a Yorkie, and it's a puppy, so it's only 1 year old, and it's white. I think I called that the same variables here we used. So here's our constructor, here's our code. Oh, I did pick white, so that was good. We have our existing dog object, Ruby, which is my dog in the example. Maybe I'll switch that now over so it all matches up to the slides a little better. And all I have to do for that is change my dog here to Ruby, and change it here, Ruby, and here, oops, Ruby, and one more time, Ruby. Now the code actually matches the slides, which is nice for reference later on. So we have our code here, creating our two dog objects. So if we take a look and we run this, I'm going to get the same output that I had before for Ruby. And if I wanted to print Holly's name, we're going to use the Holly object, and we're going to use the same getName method. The methods don't change, but the name of the object did. And we're going to hit semicolon, and we're going to run it, and now we see Holly. So why is this important? Well, yes, these are very simple methods, but we have the same logic now that we use for every object of type dog. Everything will be handled and treated the same. which is great. We don't have to worry about different methods, different actions. All the actions are defined for us, and we know how to do what we want to do. So that's one idea. What if we wanted to, what if we want to do something else? What if we wanted to define an order system to track customer orders at an ice cream stop? Well, what kind of data would we need? Well, we would need to give it a class name. We would need data and methods. We would need to define what each of these are so we can actually write the class definition and then create objects. Well, here are some examples of what we could use. Well, we could call the class name customer order, kind of self-describing. What data? What number of scoops of ice cream? What flavor of ice cream? Order fulfilled. Is this still an order that we have to work on, or did we give the customer their ice cream already? And what's the customer's name? We need to know what to call out at the window when we're ready to give them their ice cream. Well, we need to create a new order as a method. We need to change the status to set whether it was completed or not. Well, we need to compute the cost. We need to know how much that's going to be to charge a customer. We need to know their name. We need to be able to set the flavor, set the number of scoops, all that stuff, all these different methods that we can create. Now, out of all these, which one would you think would be the constructor? Well, when you think of a constructor, you think of which one is going to be creating the object. What is creating the template? And that would be this one right here. Create new order, customer order. You could also tell because it's got the same name as the class itself. So that at a high level is classes and objects. So I will post these slides. I'll make a few typo errors I saw. I'll fix that up as well so you can refer to it. And I'll also post the sample code that we had from Zybooks, so you can try it at your leisure. And we'll spend more time on this later in the week and in the coming week, because this is going to be a rather involved section, but I at least wanted to give you some starting time on it. Now, there are 3 labs this week, and they all start with how to complete something, meaning the code is mostly written. You have to write a little bit more to complete the activity. So in this particular one, the triangle one, you're given the class triangle, and you need to complete the main method to read and set the base and height of a triangle 1 and 2. So I just want to point out, though, when you're doing these labs now, and you'll see over here you have your paper icon, you have 2 files. Well, you have your triangle area.java, and you have your triangle.java. Now, your triangle area.java is your main program. This is the one you're going to run. Now, how do I know that? Well, I know that because it has the public static void main in here. So I know this is the main program. And this is telling you where you have to do your updates. So it tells you have to read and set a base and height for triangle 1, and read and set a base and height for triangle 2. And it's giving you a hint. Let me close this over because we don't need that anymore. Use set base and set height. Now, where is set base and set height? Well, set base and set height are in the class definition of triangle. And you'll notice it's read only. You can't make changes in here because you don't need to. Everything in here is as it should be. So you have your set base and set height, which takes a double as a parameter and sets the value. So you need to come in here and you need to use your scanner. You need to use your scanner to read the values and set the values, and then call the appropriate methods to set them and then eventually print them. And the other 2 labs are similar. So give those a try, and we'll follow up later in the week with a different example and of how we can build a student class and some data in there, and we'll see what that looks like. Okay, so that's it for now. Good luck, and if you have any questions, let me know, and I will see you next time.